So today we are going to start SURDS. SURDS basically is a way of writing the fractional power. In indices we have studied that basically it's what? A to the power of 1 by 2 is nothing but its root A. A to the power of 1 by 3 is what? It's cube root of A. So basically it's a fractional power or it's an irrational number because numbers are divided into rational and irrational. So these numbers are known as irrational. That means they cannot be written in the form of P by Q. You cannot write them in a fractional way. So that's the meaning of SURDS. That's the basic definition of SURDS. We know there are different types of numbers that are integers, rationals, irrationals, whole numbers, natural numbers. But those are that cannot be written in P by Q form are called irrational, and they are basically SURDS are one of the irrational numbers. Pi is also an irrational number. Now instead of writing, because they can be non-terminating or recurring. That means if it's like 4.141 and like you will get a continuous number. You keep on getting 4, 5, 6, 7, 9, 3, 2, 1, 2, 1. It's non-terminating. You're not able to terminate it. So irrational numbers are after the decimal you cannot terminate them. It's an endless numbers that you will keep on getting. Second thing is the numbers that are recurring in nature. It's important they all are non-terminating. You cannot end them. There is no ending. In non-terminating also, these are of two types. That means recurring, non-recurring. In recurring, you keep on getting the same number. That means suppose it's 1.31. So it will be 31, 31, 31, 31 and endlessly you will get 31. So you can write 1.31, these two dots or 1.31. Either this line or these two dots above it represents the recurring nature. Non-recurring, that means you will get the endless number 1, 4, 3, 2, 5, 7 and so on. So this is your irrational number. Surd is basically an irrational number. Okay, so just quickly note this down and then we'll see how can we solve the surds. Okay. See, in this section, I have written non-recurring, and in non-recurring, the example is pi. So it's a non-recurring, non-terminating number. Okay. Now let me see how can we solve this one. So first is we should know some rules. These are general rules of surds. So first thing is when we multiply two same surd number together having the same base number that means if I'm writing root a, so this stands your base number. So surds having same base number, your answer will be that base number. Root a times root a will give you just a. So similarly, example is suppose it's root 2 times root 2, the answer will be just 2. If you are suppose multiplying it 4 times, root 2 times root 2 times root 2 times root 2. So this will give you just 2. Multiply, this will give you just 2. So answer is gonna be 4. Or suppose it's written as root 2 whole to the power of 8. So what does that mean? It means you are multiplying root 2 8 times. If you are multiplying root 2 8 times, it's root 2 times root 2. Root 2 times root 2. And so one pair will give you just 2. Another pair will give you just 2. Another pair will give you just 2. And another pair will give you just 2. This will be 16. It gives you 16 as your answer. Okay. So always the same pair will give you just the base number. All these parts. What will be root 3 to the power of 6 and root 3 to the power of 6 into root 3 to the power of 4. Write down your answer in chat section. Okay, just be quick. Everyone has to give me the answer. So be okay. Now see. It says root 3 to the power of 6. That means you are multiplying root 3 6 times. So root 3 times 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 root 3. This one will give one pair will give you 3, another pair will give you 3, and another pair will give you 3. Answer will be 27. Similarly, what you can do is it's 6 times and it's 4 times. That means total 10 times you are multiplying. 10 times you are multiplying, that means you will find 5 different pairs of 3, right? 1, 2, 3, 4, 5. And each time you are multiplying root 3 and root 3. That means this will give you 3, 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 and this will give you 3. So final answer will be 3 to the power of 5 or 243 will be your answer. There's another way that you can use as well in order to solve this using your indices method. We know there is a formula a to the power of m whole to the power of n, and you just multiply their powers. We know root 3 is 3 to the power of 1 by 2 whole to the power of 6. I'm just applying the fifth rule of indices. So it's going to be 3 to the power of 1 by 2 into 6, 3 to the power of 3, which is 27. And similarly, if I'll apply here, it will become 3 to the power of 3 into 3 to the power of 2, which will give you 3 to the power of 5. And 3 to the power of 5 is 343. But since the question is given in the form of surds, so we can do in this way. Now moving on to the second part. The second rule is when the surds are of different nature, the bases are different. That means root A into root B. Clearly the bases are different. In that case, you will get root AB. Okay. C is when you are dividing different roots. Root A over root B. So root is common and divide A by B. That means suppose question is root 6 times root 3. So root will be common and 6 times 3 will give you 18. So root 18 will be your answer. Root 2 over root 10. So this will be root will be common. Divide 2 by 10. You will get your answer as root 1 by 5. So what you are doing? If you are multiplying or dividing the surds of different nature, different base number, root will be common, but then you have to apply or you have to multiply or divide them separately inside the root. Okay. So just be quick, write this down, then we'll see how we can simplify the surd. Okay. Now coming to the simplification. Simplifying surds. Suppose it's given as root 24 and you want to simplify it. If it can be simplified further, the best is simplified. So first step in simplification is prime factorize the base number. Prime factorizing the base number, that means this is your base number. If you prime factorize it with the help of factor tree method, you will get your answer as 2 times 2 times 2 times 3. This is how we can prime factorize. This means that it's actually root 2 times root 2 times root 2 times root 3. And we know with our first rule that if you are multiplying two roots together of same nature, it will be your base number. Root 2 times root 2. You are multiplying same roots together, it will be just 2. Then multiplied root 2 and root 3. Here you have to apply the second rule because the root numbers, the base numbers are totally different. So what you will do? 2 into root of 2 into 3, which is 6. So finally your answer will be 2 root 6 will be your simplified answer. So let me know, is it clear or not? Write yes or no. So similarly, you have to solve this one and give me the answer. It's root 1024. B is root 500 and C is root 600. Solve these three and give your answer. Everyone has to give me the answer in chat section. Okay, now let me see. The first step that should be there is you have to prime factorize the base number. When you prime factorize this base number, you will get 2 multiplied by 10 times. That means 2 to the power of 10, the root of this one. And we know one pair of root will give you just single 2, right? That means if you are multiplying root to 10 times, so one pair will give you just 2. It means you have to multiply 2 5 times to get the answer, which is 2 to the power of 5 or 32 will be the answer. Similarly, if you prime factorize 500, you will get 5 into 5 into 2 into 5 into 2. This is how you can do. 1 5 will give you just 5. One pair of root 5 into root 5 will give you 1 5. Root 2 into root 2 will give you just 2. And root 5 will be as it is. That means answer will be 10 root 5. Similarly, we can say for 600, if you prime factorize root 600, you will get 3 into 2 into 5 into 5 into 2 into 2. So if we have to make pairs, one pair of root 5 will give you just 5. Another will give you just 2. And this will give you root 6. So answer will be 10 root 6. So answer the first one is 32, for the second one is 10 root 5, and for third is 10 root 6. Okay, now just be quick and write this down, then I'll move on to the next part. Okay, now the next is how can we add or subtract the surds? It's important. This is addition and subtraction. Surds are almost like indices because surds are what? Basically a fractional indices. So they work exactly the same. If you know the indices, it's very easy for you to do surds. You can add same surd together, same surd you can subtract, but you cannot add or subtract the different surds. That means suppose it's root a plus root a. You are adding having the same surd, same base number. So because you have added it 2 times, it will be 2 root a. Or root a plus 4 root a. So 4 plus 1 more root a, that means 5 root a. You can add them up. But when you have to add the two different surds, that means root a plus root b, you cannot add them because they both have a different base number. So leave it like that. You can't do anything further. Okay, so just don't do like this a plus b inside the whole rule. It doesn't make any sense. There is no rule regarding it. So you cannot add or subtract the same, but the surds having the different base number. Similarly, when you have a different indices, you cannot add them, right? It was m to the power of n plus m to the power of p, something like that, right? You cannot add them. Here it's the same, you cannot add the different base numbers, so leave it like that. But you can subtract also the same base number, which will give you 3 root a. Say for example, the question is add 6 root 3 plus 5 root 3. Clearly root 3 have the same base number, so you can add them. 6 plus 5 is 11. 11 root 3 will be your final answer. Or you want to subtract 7 root 3 minus 2 root 3. So 7 minus 2, 5 root 3 will be your final answer. But if the question is add 7 root 2 plus 3 root 3, you can clearly see they both have different base number, different surd numbers. So you cannot add them. Different surd numbers. You cannot add or subtract them. So quickly write this down and then solve these two questions that I'm writing in green color. After writing this down, solve A and B and write down your answer in chat section. Okay, now let me see. As I've explained, we can add same surds. So first we have to check whether they have the same base number or not. Root 5, root 5, root 5, yes. So we can add 9 plus 11 will give us 20 root 5 minus 6 root 5, which will be 14 root 5. So this will be the answer for the first one. For the second, again, we have to check whether they all have the same base number, root 2, root 2, root 2, which is, so 11 root 2 minus 12 root 2 will give you minus root 2 plus 22 root 2, which is finally 21 root 2. So this is the answer for the second one. Now just be quick, write this down, and if you have any doubt, ask me in chat section. Okay. Now, if we have to add these type of surds, suppose it's root 12 plus root 27. If you see, definitely you cannot add them as they both have a different base number. But that doesn't mean that you can't add them up. We did one thing that is known as simplification. Simplifying surds. So first you have to see whether you can simplify it or not. So while adding, first thing is simplify surds. If you cannot simplify and have the different base number, that's fine. But if you can simplify, that means go for the simplification. So first thing is simplify surds. When you simplify this will be 2 times 2 times 3 plus this will be 3 times 3 times 3. This will give you 2 root 3 plus 3 root 3. Now you can clearly see they both have base number. And that's the reason we have to simplify first. Before the simplification, they both have a different base number. But after simplification, we can see that they both have the same base number. And now I can add them up. So which will give you 5 root 3. That will be your final answer. Similarly, if the question is root 27 minus root 12, so after simplification, we can write root 27 as 3 root 3 and root 12 as 2 root 3. 3 minus 2 is 1, answer will be just root 3. So the important thing is while adding and subtracting, you have to simplify the surds. Is this clear or is there any doubt? You can write if it's not clear. Okay, now similarly solve this one. Solve this one and give me the answer. Let me solve it. Root 48 minus root 12. Root 48 The first step of simplifying is, you all have written, right? I told you all to write down the steps. That is very important. So the first step is, you have to simplify, or you have to prime factorize 48. If you prime factorize number 48, you will get 2 times 2 times 2 times 2. Okay. And 12 can be written as 2 times 2 times 3. Okay. Now, as I told you, one pair will give you the one number, right? Inside the root 2 into root 2 is just single 2. This will be single 2. And this, it has no pair, so put it inside the root. Similarly, this you have pair, and 3 is a single one, so put it inside the root. So answer is 4 root 3 minus 2 root 3. Final answer will be 2 root 3. Let me know, is it clear, the simplification part as well as how to add or subtract the whole thing? Write down yes or no. And okay, now solve this one. Find perimeter of a rectangle whose length is root 48 and width is root 12. Write down your answer. Okay, see. Find the perimeter of a rectangle whose length is root 48 and width is root 12. So that means what you have to do is, first let me draw rectangle. Length is given as root 48, width is given as root 12. Perimeter, which means you have to add them up. Add them up, that means add all the boundaries or all the sides that you can see here. So lengths, we know in rectangle opposite sides are equal, so this will become also root 48 and opposite will become root 12. So add them up, root 48 plus root 48 plus root 12 plus root 12. They all have the different base numbers, right? These two have same, these two have same, but we can simplify them further. We have just seen that root 48 can be written as, on simplification, it will be 4 root 3, and 12 can be written as 2 root 3. So 4 root 3 plus 4 root 3 plus 2 root 3 plus 2 root 3. Ultimately, it will be 8 to 12, 12 root 3 centimeters. It's given in centimeters. So answer will be in centimeters. So your perimeter is going to be 12 root 3. Now just be quick and let me know, is it clear or not? Write down yes, or if it's not clear, write down no. Root A times root B will give you root A times root A will give you just A, and root A over root B will give you root A by B. These three rules we have studied. On the basis of that, let me solve few questions. Suppose the question is 2 root 3 into 3 root 2. How can we multiply? When it's the multiplication, add the numbers and numbers, as well as add the multiply the numbers and numbers, and similarly multiply surds and surd together. 2 multiplied by 3 will give you 6, and root 3 times root 2 will give you root 6. We have to apply this one. Definitely root 3 and root 2 are two different surds. When you multiply them together, it will be root and multiply the numbers. A common root and multiply the numbers, you will get 6. So answer will be 6 root 6. Similarly, if it's 3 root 5 multiplied by 2 root 5. So it's gonna be 3 times 2. What you have to do? Multiply numbers together. So 3 times 2 will be 6, and root 5 times root 5 will be just 5. Answer is gonna be 30. Let me know, is it clear or not? See, I have very limited time, right? Surd will take at least 4-5 hours, to be honest. Okay, we have just 1 hour or like 1 hour 15 minutes, so I have to like summarize all this up in just one lecture. So I'll be sharing you all the recordings, okay, after this, that so that you can go through it, okay. And also I'll share the worksheet, so it will help you. See, when you multiply surds together, you have to apply these three rules, right? Same surds will give you just the number that we know, right? 2 times a pair will give you the number. If you are multiplying two different surds having having different base number, it will be a multiplied by b and inside the root. If it contains number, integer number as well, so it's just that it exactly works like algebra. Exactly algebra. What is 2x times 2y? What we do? We multiply number 2 into 2, 4 and multiply xy. 2x into 3x. We multiply 2 and 3, 6 and x into x is x squared. It's exactly the same. That means what you have to do when you have 2 root 3 into root 2, treat root 3 and root 2 as your x and y, right? This is x and this is y. So if it will be 2x times 3y, your answer will be 6xy. X is what? Root 3. Y is what? Root 2. And we know root 3 times root 2 is 6 root 6. So simple, what you have to keep in mind is that it works like an algebra. In algebra, we multiply numbers and numbers together and the variables together. And similarly here we have to multiply the numbers together. 2 into 3 will give you 6. And multiply the third numbers together, root 3 into root 2. So finally you will get your answer as 6 root 2. The same I can say 5 root 2 times 10 root 2. What I'll do? Again, I'll do 5 into 10, which is 50. Multiply surds and surds together. So root 2 into root 2 is just 2. Answer will be 100. So treat them as algebraic expressions and you'll be able to solve it. So note this down, everyone. Now, these two questions you have to solve. Root 18 times root 27 and B is 2 root 30 over minus 4 over root 3. Solve these two. First thing, whether you are adding, you are subtracting, you're doing anything, everyone pay attention, right? It's important. I'm again saying because I have limited time, so I'm quite faster. So just pay attention what I'm saying. It's whenever we are adding, we are multiplying surds together, right? The first thing is you have to simplify. If you see the surd, the first thing that should come up in your mind is that you have to simplify it. Okay? And if you have to simplify, that means simplify here as well. If you're multiplying, simplify here as well. So simplify 18, 2. This will be 3 into 2 into 3. This is gonna be 3 times 3 times 3. So this will give you 3 root 2 as your answer, and this will be 3 root 3 as your answer. Now we know that we can multiply numbers together, integer numbers together and irrational numbers together, surds together. So 3 times 3 will give you 9 and root 2 times root 3 will give you root 6. So answer is gonna be 9 root 6. Everyone let me know, is this clear or not? Okay, similarly we have to do it here. Root 30 can be written as 2 times 3 times 2 into 5 over minus 4 times root 3. See, clearly you cannot simplify root 3 if you see this one. But we know one thing for sure is that root 30 can be written as root 3 times root 2 times root 5 over minus 4 root 3. What am I again saying? Simplify or write it in this way. Okay. So you can clearly see 1 root 3 gets cancelled out. 2 and 2 gets cancelled out. So final answer will be root 10 over minus 2. So that will be your final answer. So always go for simplification before adding or subtract. So all of you note this down, then we'll see rationalization. See, the last one is whether you can simplify or you can't, you have to split that. So what I did, I split it root 30 into root 3 to 5. 5 prime factorized it. Minus 4 over root 3. Now this can be written as 2 times root 3 times root 2 times root 5 over minus 4 root 3. Obviously, why I have written? Because I can clearly see I can cancel out root 3 and root 3. So root 30 can be written as root 3 times root 2 times root 5. This root 3 and root 3 can be cancelled out. This 2 and minus 2 can be cancelled out. Answer will be root 2 times root 5 is root 10 and only minus 2 is remaining. So final answer is minus root 10 over 2. Okay, now the next is rationalization. Now just pay attention why we have to rationalize, because we don't want a surd number in denominator. To eliminate surd from denominator. As it's not acceptable. To be honest, like it's not acceptable, that means in mathematics you cannot accept it. So you have to remove the surd number from the denominator. So suppose your question is 2 over root 3. So 2 over root 3, that means root 3 is in the surd. So how you can eliminate it? By dividing and multiplying with the same surd number that is there in the denominator. So how we can do it? By dividing and multiplying surd in denominator or surd of denominator. Multiplying number with the surd in the denominator. So 2 times root 3 will give you 2 root 3 and root 3 times root 3 will give you 3. So this is going to be a final answer. Similarly, suppose it's 5 root 2. 5 over root 2. First thing is check the denominator. In the denominator, there is a surd number which is not acceptable at all. So, divide and multiply with root 2. Answer will be 5 root 2 over 2. Because root 2 times root 2 will give you just 2. And 5 times root 2 will give you 5 root 2. This will be your final answer. Note this down quickly and you go. So rationalization is of two types. Two types, that means if in denominator only just one surd is there. Just like here, you can see there is only one root 3, one root 2. But what if you have something, an integer as well? Okay, so rationalization can be of two types, right? Rationalization when in denominator there is a pure surd. When in denominator we have only surd number. This is the first. And second is when we have surd and an integer in addition or in subtraction. This means when we have only surd number in denominator, that means it looks like this. There is only one surd number. But when we have an integer and surd, if they are in addition, that means 2 over root 3 plus 1. 5 over root 7 plus 2. There is an integer number and a rational irrational number. We both are adding or subtracting them. These are two types. This can be rationalized, just we have seen it, right? Multiply and divide with the number that is in denominator. So multiply and divide with root 3 in this case. So 2 over root 3, multiply and divide. In this way, you will be able to rationalize it. But if you have 2 over root 3 plus 1, 2 over root 3 plus 1, in that case, you can't divide and multiply with the same number. This will not eliminate the surd number from denominator. Rationalizing is what? You have to eliminate the surd number from denominator. In this way, you won't be able to do it. So what you have to do it, just change the sign. So 2 over root 3 plus 1, multiply with root 3 minus 1 and divide with root 3 minus 1. Only change this sign. Similarly, if it's 5 over root 7 plus 2, so 5 over root 7 plus 2 multiplied by root 7 minus 2 over root 7 minus 2. You have to multiply and divide changing the sign. If it's an addition, again keep in mind, if it's an addition, integer and surd numbers are in addition, you have to divide and multiply changing the sign. So in this way, now you can multiply 2 times root 3 minus 1 over root 3 plus 1, root 3 minus 1. You know how to expand the brackets. You have already done the two brackets. So 2 times root 3 is 2 root 3. 2 times 1 is minus 2 over root 3 times root 3 is 3. Root 3 times minus 1 is minus root 3. 1 times root 3 is plus root 3. And 1 times minus 1 is minus 1. So you can clearly see plus root 3 and minus root 3. You can cancel it out. Answer will be 2 root 3 minus 2 over 2. Or you can cancel out 2. It will be root 3 minus 1. That will be your final answer. Let me know. Is it clear? Yes or no? Write down yes or no in your chat section. Let me repeat it once again. If it's 2 over root 3, you have to multiply and divide with the same. But the second case is when you have 2 over root 2 plus 1. You have added an integer to it as well. So in that case, multiply and divide with the opposite sign. That's it. Okay, that's all you have to do. Multiply with the negative sign. There is a plus here, multiply. Similarly, it was 2 over root 2 minus 1. So change the sign. 2 root 2 plus 1, root 2 plus 1. What I did, the sign check that is separating your integer and the surd, just change that sign. In the first case, it was plus. So I changed the sign and changed it to negative and divide and multiply with that. In the second case, there was a negative sign in between it, so I have changed it to the positive sign and divided and multiplied with that number. Okay, the rest is just the multiplication, just the basic multiplication that you have done in your algebra. That is, and that you have been doing, to be honest. So that is 2 times root 2 minus 1. 2 times root 2 minus 1 over root 2 plus 1 times root 2 minus 1. Root 2 plus 1 times root 2 minus 1. Now you just have to expand it. You always have to change the sign. See, it's the question is rationalize. That means you have to change the sign. It's a mandatory. Okay, so it's the case. This is the rationalization. Rationalization, that means you have to remove the denominator and you have to follow this step. You have to change the sign. Okay. Now you just need to expand the bracket. It's simple. So how we expand the bracket? Multiply the number outside with the every term inside. So 2 times root 2 will give you 2 root 2. And 2 times minus 1 will give you minus 2. Over. Root 2 times root 2 is just 2. Root 2 times minus 1 is minus root 2. Plus 1 times root 2 is plus root 2. I'm assuming you know how to expand it. Okay. Plus 1 times minus 1 is minus 1. Simplifying, we'll get 2 times root 2 minus 1 minus plus root 2 will become 0. 2 minus 1 is just 1. Answer is this. Let me know, is it clear? All of you? Write down yes or no. Okay, it's just a basic multiplication, right? Once you know with which number you have to rationalize, then the thing is just the expansion. Okay, you have to expand it. If you're not able to get it, you can go through the recording, right? I'll share the recording. It will help you in going through it once again. Okay, so basically that's it in the sorts. These all things you will find in the sorts: the addition, the multiplication, rationalization, simplification. That's it. And we have covered all the things. What's important, if you haven't made the notes, just go through the recordings and make the notes and then try to solve the questions. Okay, so that's it for today. Thank you everyone and have a great day. Bye.